Hello and welcome to another video in my tutorial series. If you remember, in the last two videos in this particular series I've been talking about typing in the programs from these two classic Commodore 64 books into CVM Program Studio, and in the last two videos we was talking about the first book, where I ran through the programs in the first book and we was deciding which of the programs we should convert into machine code, and I said that I would do a demonstration of this, and that would have been on the first program, which was like a Kaleidoscope Generator. So if we just have a quick refresh of the program itself, so here it is. So it sets the background, protects basic, creates a mask, sets up the VIC chip, clears out the screen memory, clears out the graphics memory, and then starts plotting points. So if we run this, and be warned, it's gonna take some time, you will see, so here we are, so it's now clearing out the screen memory, and it's now cleaning out the RAM in the background that is being used for the high resolution graphics. And so we are currently halfway through the screen, and then what it's going to do, it's going to just plot some random points, but it's going to repeat them to make it look like a kaleidoscope. And this is how long it takes to generate these points. And the whole point of this tutorial is to convert those 20 lines, if that, into machine code and see what the execution difference is. So as you can see, we've not really got that far in a minute. I could leave it for a little bit longer just to see what it comes out like, but I'm sure it's going to be pretty boring for you guys. So that's the challenge. Well, since I did those videos, I have risen to that challenge and created this. So this is the machine code conversion of that program. So just to run through it. So I'm creating some debug watch variables, because when I was debugging it I wanted to know what was going on. And if you notice, the variable names are exactly the same as what's in the basic program. The only difference is I've put prog in front of them, because you can't, it's very difficult to have single letter variables in machine code, because X could be taken a different way. This is the basic loader, so it just says SYS 2064, I think it is, in basic, and this is where we're going to start the program. So I'm setting an assembly reference, which is called VIC, which is D1000. This is the start program, so this is jumping to the actual start. The next section is the program variables. So I've got BA, this is my masking array here. So in fact, we'll make that into two lines. So right, there we go. And this is that the array that you saw on line 20. This one here, line 6. So I'm not actually running a program, I've preset that array in memory. Then we've got some more variable points all the way down, and they're all the same. And we've had to create some routines. Now inside BASIC we use the random function, which is here. Now machine code doesn't have a randomizer, and so you have to develop one. And what I've done is I've borrowed Grady Fender's randomizer code out of his GPAT clone game. And basically what this does is it initializes to the maximum frequency of one of the sound voices. So in this particular case it's sound voice 3, and sets the waveform to noise. Right? So it sets that up, and then every time we want a random number we run this routine which gets the value in the voice, which could be anything between 0 and 255. And it works, and it's so simple. So thank you for Grey Defender for that piece of technology. We've got some defined macros because when I was writing it I found out I was replicating the same set of code again and again and again, and this macro fills a video bank of memory full of the accumulator. And what it does, it indexes through the X register. So it starts with X equals 0, and we store in the value in the accumulator into the first 255 bank, the second 255 bank, the third 255 bank, and the fourth 255 bank. It then loops round again and again until it reaches 0 again, and if it hits 0 it ends. And people who've watched my video series will remember this routine that we did before. I've also got another routine that evaluates the delta number, because this code here is replicated many times in the program. So instead of replicating it many times in assembler, I've made it as a macro, and basically it goes to the randomizer, it filters out everything bar the last two bytes of the bit, last 2 bits of the byte. Then it sets the carry and then subtracts 1, because so this is the randomizer here, so that does the randomizer, and then it says times by 3. Now we're not going to times by 3 because we're going to get a number between 0 and 255, and it's a random number. So if we mask off the last 2 bits, that gives us a random number between 0 and 3. And that's what this statement is doing, is doing a random number and then making it between 0 and 3. And then what it does is then minuses 1 off it. So it becomes a number between -1 and +1, which is 3 individual numbers. So that's why we subtract 1 here, and then we store it in the address that's specified in the macro. I've got another macro here which is basically to copy a word, which is a 2 byte value. So it loads the low byte, stores it in the low byte, loads the high byte, and then stores it in the high byte. And we use that quite a lot. And I've created another macro called subtract number word, and basically what it is this is going to subtract a number from this word and store it in this target. And so it's going to load the low byte of the number, subtract it from the source, and then stores it in the target, and then it does it again for the high byte. And so they're predefined macros in there. So here we go. So this is the main start of the program. So the first thing we do is we initialize the randomizer, which is initializing that third voice into being a noise generating voice. So this is line 0, and so what I've done is made sure that the line locations marry the locations in the basic program. So this is line 0, and basically what it's doing is storing 1 into the program variable BA, and that's what this is doing. So this is BA, because remember basic only is a 2-character variable, and it's storing 1 into BA. And then line 5 is something to protect basic, but we're not going to bother with that because this is a machine code program. So line 6 is setting up the masking, but we're not going to do that because this is what the machine code would have been But then I thought, why? When I can actually directly set the masking in the data itself, so we don't need to do any execution. So this is what it would have been if we needed to, if we was going to modify those data points, but we're not. So I've just created the masking actually in the data here. So that's the data there, and that's all it's doing. It's just putting a bit in each one that represents that value. So come back to here. So line 10 is setting up the screen, so it's going to put 0 into the border and then the background. So if we look at line 10, so it's setting up V, and then it's setting 0, poking 0 into the border and the background. Line 30 is setting up the video banking, I think. Line 40 is setting up which part of memory it's going to be looking at. So if we look at line 30, it's exactly the same, and 40 is exactly the same. And then here we are filling the screen with the value BA, and that's where this macro comes in. So we're going to we're loading the accumulator with BA, and then we're going to fill the bank 0400 with that number, which is the equivalent of this line here. And then line 60 is filling the memory with 0. So the high resolution memory is going to fill with 0. And I'm doing this by saying load accumulator with 0, and then it generates the macros for each one of the banks inside of the memory. And so we're starting at 2000 because that's what 8192 is, and 8192 times 8 is 4000. So this would be the last one because it would end up being 4000. Then line 100 is where the points start. So that's going to set X to be 79, so that's this bit here, and then it's setting Y to be 49, which it's doing here, and then we're setting the high values of X and Y to 0, because the reason why we have to do this is because X is between 0 and 320. Now 320 is bigger than 255, so it ends up being a word and not a byte, and the Y value I think is between 0 and 192. But that happens to be a byte. But because we're trying to keep things consistent, we're going to use it as a word instead. Then we're going to evaluate the delta, which is this bit for X. So we're saying create the delta routine, and we're going to store the result in that position. dy is exactly the same, so we're doing it and we're storing it there. And then we're doing a test. If dx is equal to 0 and dy is equal to 0, then go to 100. And this is what this is doing here. So it's saying here, load dx. If it's not equal to 0, then move to 105, because that is part of the criteria, because this and this has to work. So if this fails, it won't even evaluate that because it will just move on. So if it is 0, then it loads dy. Is it equal to 0? If it is not equal to 0, move to 105. If it is, then it jumps back to 100 and then reevaluates dx again and dy. Then line 105 is doing this. So it's in segments. So you've got to imagine that this is segment 1 here. So that's segment 1. So it's copying prog y into prog y1, which is this bit here. Then it's copying prog x to prog x1, which is this bit here, and then it's going to go sub line 1000, which is this bit here. Then we're doing subtract number, and 013f I think is 319, and you're taking it from x and storing it in x1, and then we're doing the go sub again, which is here. Then we're going to subtract 99 from y, so that's 99, value 99, from y and placing it into y1. Then we're doing go sub 1000 again, which is this one, and then the last bit on the end is making x1 equal x and then going to 1000 again. So we're basically copying here x1 back into x, and then we're doing the plot. Line 107 is where we're doing some multiplication. So we're multiplying y by 2 and putting it in y1. And this is dead easy. You load y, shift it left, that multiplies it by 2, store it. Load the high byte, roll it left because we want to take the carry from the shift left and put it into the high byte, and then store that. And then we do it exactly the same for the x variable, and then we go sub 1000. And then the next line is doing 190, y1 is 199 minus y1, so 199 from y1, storing it back into y1, and x1 is a 319 minus x1, so we're taking 319 from x1 and putting it back into x1. And then we're doing the plot. And then we're doing the dx modification. So here, x equals x plus dx. That's what this bit does here. And what it's doing, it's loading dx, then adding it to x, and we're storing x low byte back. Then we're loading dx again, and we're testing whether it's a positive number or a negative number. If it's a positive number, it's going to miss this clear carry and move to here. But if it's a negative number, we have to clear the carry because it will add, because we're doing 2's complement, a negative number will always go over the page minus whatever it is. So we need to clear the carry before it can do the high byte addition. We do the same with dy, exactly the same code. So effectively I could have made these into macros. So that's point number 1. I'm going to make those into macros. And then we do a test. So here we are, we're saying if x is less than or greater than 159, invert dx. So here we go. So we load x plus 1. Is it a minus number? Yes it is. Right, so we need to, because that means it's less than 0, so we come into here. We load low byte prod x, compare it with 159. Is it greater than 159? If so, come here. If not, go to line 115. And then this is doing the invert. So we load prod dx, we not it, then we clear the carry, add 1, and then store it back. And that's doing 2's complement, because if you have minus 1, which is ff, and then you not it, it becomes 0. So we've got to add 1 to make it become 1 again, and that's 2's complement. Line 115 is exactly the same, but we're doing it to the y variable. And what it does, it actually re-evaluates dx again. And so we re-evaluate it, so we're doing the random. Is it, and I've worked out 90% of 255, which is 225. So it's saying if the random number is less than 0.9 or 225, go to the next line. If it's greater than, then we're re-evaluating dx again, which is this bit here. And it's the same with y as well. So randomize, is it less than 0.9? Come to here. If it's greater than 0.9, we're going to evaluate dy. Here we're making sure that dx is not equal to 0 or dy is not equal to 0. So if this is not equal to 0, then it goes to 105. If this is not equal to 0, it goes to, or both. Yeah. So we load dx. Is it not equal to 0? Then we go straight to here, which then goes to line 105. Same with that, goes to here, goes to 105. And if it passes both these tests, then we're going straight to line 140 here, where we're doing another evaluation of dx and dy. And then we're doing another test, but this time it's, are we saying, is it equal? So, is it not equal to 0? Of course it's not equal to 0, so it comes here, and then we go to a line 105, because that's line 50. If it is equal to 0, it comes through. dy, is that not equal to 50? Yeah, not equal to 0, there, yes. If it is equal to 0, then both of them equal to 0, so it jumps back to line 140. 150 is go to 105, which is basically that. And then JSR 1000 is where we're working out the plot location. So 1000 is this. So the first thing we do is we divide Y1 by 8. So we load Y1, we store it in YA, and we load the high byte of Y1, and this is where we start the division. So we logically shift it right, which divides it by 2, and then we roll that number into YA, which divides that number by 2. Then we logically shift Y1 again because it's in the accumulator, and we take the carry and we roll it right in YA, and we do it again. So we do it, first time is divided by 2, second time is divided by 4, third time is divided by 8. That leaves us with the value in YA. And then we've got YB is equal to Y1 minus YA times 8. Well, that's dead easy, because effectively it's loading Y1 and ANDing it with 8 and then storing it in YB. Because what you've done here is you've moved these 3 digits, these 3 bytes out. So all we have to do is just AND it, and that is the remainder. And so we do this. So we do the same with X. We divide it by 8, and XB is exactly the same as YA. In fact, that could have been a macro as well. So point there. We could 2 more macros we can write. And then line 1005 is 8 times 1024. Well, 8 times 1024 is hex 20 0. So what we're doing, we're storing 0 in the position low and the position high. Then we break it down. YA times 320. So this is it. So we add 320 to prog position and prog position high, the number of YA times. So that's effectively multiplying by a number. Then the last bit is XA times 8, which is down here. So we bring in XA and we logically shift left 3 times, which is times 2, times 4, times 8. Now we put the result on the stack because we need to come back to it later. Because if the carry is set, we need to add it to the high position. So what we do is load 0. If the carry is set, it basically adds 1 to the high position. If the carry is clear, it adds nothing, and then we store it back. Then we bring what we put back on the stack back, and then we add it to the low position. And then we do another high position add because of the fact that we could have crossed the page boundary again. And then YB is exactly the same. And then to get this bit, basically we load Y with the XB, we interrogate the array indexed by Y, and then we store it in XC. And then the last bit, which is poke, so this is line 10, so we poke the address with looking at the address or in it with XC. And that's what we do here. So we store our prog position low and high in 14 and 15 because we need a 0 page call. We set Y to 0 because our point of memory point is stored in 14 and 15. So we load the contents of the memory location at 14, 15, redirect. Then we OR it with our prog.c, and then we store it back and then return back. So that's basically it. So what we can do is we can run it. So if we run it, there we go. Look how fast it's going. Isn't that a thing of beauty? Now we ran the other one for a minute. Now if I run this for a minute, it's going to fill the screen. And that is how you convert a basic program into assembly. Now I'm going to put this code on my GitHub so you guys can look at it and interrogate it, because I still think there's a little problem with it, and I'll see if you guys spot it when you load it and have a look. So with that, I hope you've enjoyed this tutorial. I hope that you play with the code and let me know what you think. There you go, a minute, and we're almost filling it up. So I'll see you on the next video, and I'll see you next time. Take care. Bye.